Deep in the Californian wilderness, engineer Dan Dickrell is riding the rails on board a specially adapted truck. Following a route once dubbed the Impossible Railroad, to discover a truly extraordinary feat of engineering.
Right now we're about 85 miles outside of San Diego, and the terrain outside is as wild as it gets. But where we're headed to this morning is well worth this difficult journey.
In 1906, San Diego entrepreneur John D. Spreckels decided he could defy the odds and build a railroad to transform the city's fortunes. Stretching from the coast to the city of El Centro in southeastern California, it would span 148 miles across rough terrain.
Conditions out here are extreme. Temperatures ranging from well over 100 degrees Fahrenheit to well below freezing. There's landslides, earthquakes, floods, the list goes on.
Many thought these incredible natural challenges would defeat the engineers. And even for Dan and the maintenance crew in a modern high-rail truck, it doesn't take long to discover how this impossible railroad earned its reputation.
Working my way ahead of you and
just right there and then work your
clear,
way back.
clear. All right, I got you. How often do you have to do this?
You know, it depends on the wind.
Yeah.
A lot of times we'll come here and it'll be full from there all the way to the other end.
The fact that we're not too far outside of civilization and we're already clearing debris of the tracks is a pretty good indication of how interesting things are going to get here quite quickly.
But drifting sand was only the start of the challenges facing the original engineers of this desert railroad. As the track rises through the Anza Borrego Desert State Park, this scorched terrain presents even more problems.
It's always a big problem here with falling rocks, rock slides, landslides. There's a lot of instability. It's always a challenge to keep the line open.
You throw around the word impossible, but then when you get up into this terrain and see just how steep and rocky and effectively alien it all is, it is truly impossible. And the fact that it's here, though, meant somebody got it done.
And during its 12-year construction, the Impossible Railroad's biggest hurdle was the 11-mile-long Carrizo Gorge.
We reached the end of the line for our truck.
A brutal environment that still wreaks havoc today.
There's one huge obstacle in our way. This landslide, we're gonna have to scramble over, crawl through the tunnel, and emerge on the other side to get where we want to go. Oh, this is my kind of fun now.
In the face of this unforgiving landscape, the railroad's original engineers could have easily given up. But they had a monumental solution to beat nature into submission.
This is the Goat Canyon Trestle. A properly breathtaking engineering marvel. I truly love this structure. Its beauty, its majesty, it's magnificent.
At 180 feet tall and spanning more than 650 feet, the Goat Canyon Trestle is widely regarded as the world's largest curved wooden trestle. Incredibly, it was built in just over 100 days, following yet another of the Impossible Railroad's natural disasters. Before its construction, there was a train route through Goat Canyon along a precarious ledge and through a nearby tunnel. But this passageway, called Tunnel 15, didn't last.
Just ahead, we can see Tunnel 15. When a huge landslide broke loose, it partially collapsed the interior of the tunnel, but also dislodged the portal itself, sliding it down the mountain, causing irreparable damage.
The closure of Tunnel 15 was potentially fatal for the project. But with so much money already invested in its success, a bold decision was made. Bridge Goat Canyon to reopen the line. But to build here, engineers had the challenge of transporting materials to this remote, rocky location. Anything heavy would be impractical, so they opted for wood. This was a perfect lightweight solution. But with desert temperatures reaching up to 120 degrees Fahrenheit, any crossing train could spark yet another problem: fire.
Now, engineers came up with a very innovative solution. Up there's a water tank, and you can see the pipe that comes down and connects to a series of valves and hoses at various levels underneath the trestle.
Manually operated by a caretaker stationed at the canyon, the gravity-fed sprinkler system would be activated prior to a train crossing the Goat Canyon trestle.
So here we can see remnants of the old sprinkler system. Water stored in the tank is gravity-fed down through pipes, which you can see extends all the way behind me down the trestle. When the caretaker opens the master valve, the water is distributed through valves and sprinkler heads that dampens the entire structure, preventing a catastrophic fire. It's brilliant.
But the demands of carrying trains weighing over 80 tons across the lengthy wooden trestle posed more challenges when it came to construction. Nailing the trestle's timbers together simply wasn't an option.
Imagine a train passing overhead. The weight of the train, its heavy load, would cause a significant amount of vibration. If the wooden structure was nailed together, it'd be extremely rigid, ultimately shaking itself apart and removing the nails almost entirely.
Instead, engineers bolted 30 miles worth of timber together, forming a semi-rigid structure that allowed any vibrations to pass safely through the trestles and into the ground below.
It may seem like a small thing, but the use of bolted fasteners is a big reason why this structure is still standing today.
The Goat Canyon trestle here in Southern California allowed passengers and freight to safely cross the Carrizo Gorge for decades. In an extreme wilderness, this engineering marvel undoubtedly played its part in keeping this ambitious line open. It survived all nature could throw at it until 2008, when this section of line was finally closed. But now there are plans to reopen it.
Today, hope remains that once again this rail line can carry freight across this unforgiving landscape, giving new life to the impossible railway. Whether those plans succeed or not, the Goat Canyon trestle remains a monument to human effort, endeavor, and engineering.
But other railroad challenges require completely different solutions. In a remote part of the world where almost nothing survives, getting a railroad to the top of a mountain can be a tall order. Many wilderness railroads cross great distances of flat terrain. But when they have to go up, it's a whole new world of challenges. At almost 10,000 feet, the steep climbs up the sheer cliffs of the Bernese Highlands in the Swiss Alps are only accessible to mountaineers. You only have to look at this lofty wilderness to appreciate why it might be the last place to build a railroad. But in the late 19th century, one intrepid train engineer not only took on this unforgiving terrain, he chose to build a railroad up through 3 of its most extreme and iconic mountains.
Here we are, standing in front of the famous 3 mountains. The Eiger on the left, the Mönch, and the Jungfrau. All 3 of them roughly about 4,000 meters high.
At over 13,000 feet above the ground, these 3 mighty summits fascinated the lucky few who made the tough journey. But near the turn of the 19th century, the majestic mountains also began to attract the general public. As interest grew, entrepreneur Adolf Geyer-Zeller was determined to build a railroad to bring these mighty mountains to the masses. His remarkable achievement is the Jungfrau Railway. A railroad that climbs 4,600 feet through a vicious wilderness of rock, ice, and snow. And at the end of the line is Europe's highest train station. Train controller Christopher Sudhall has experienced the challenges of working at this location firsthand.
The weather can change within seconds, really. It can be from a summer 25 degrees here to a winter of minus 25, with extreme weather, high winds, thunderstorms, snowstorms, snow drifting. Today, we're lucky.
Instead of building to withstand the weather, Geyer-Zeller's innovative solution was to avoid it altogether. He decided to build a train that could climb through the inside of a mountain. From the base station at Kleine Scheidegg, at 6,500 feet above sea level, the first mile and a quarter of the train route is above ground. But then, the plan called for over 4 miles of tunnels to be blasted through the 3 enormous mountains.
This was very difficult and very dangerous, you know. There was about 300 employers and 30 people died.
But as tour guide Roland Fontenive is about to find out, although building a railway inside a mountain avoids the weather, it creates yet another seemingly impossible problem.
Now we go up to Jungfraujoch, top of Europe, by the Jungfrau Railways.
Geyer-Zeller was operating in a golden age of steam, but coal-powered trains and long underground journeys aren't a good mix.
You cannot go with a steam train 7.3 kilometers in a tunnel, you know.
If you do, the exhaust from the coal would coat everyone on the train.
The only option was to go by electric.
But when you're more than 2 miles above sea level in the middle of the wilderness, finding an electric supply for your train seems to be an impossible challenge. However, Geyer-Zeller turned the wilderness to his advantage, creating another extraordinary solution.
He needed to build hydroelectric power station before they could build the railway.
Geyer-Zeller built his own hydropower plant 9 miles from the railroad, providing a dedicated and ready supply of electricity.
The technique, it's more than 100 years old, so we have brand new generators, but it's the same systems like at the start at producing electricity.
Fed from a local river, the power is generated by funneling its water down an enormous 525-foot drop.
This one is from an old generator, and the water from the river is falling like this, and then the wheel is turning, and so with this type we are producing electricity.
Over 1,000 gallons of water per second flow through these wheels, feeding energy into the generator above.
As we said, in the upper part is the generator, and here you can see the high voltage cables. So in these cables are 6,000 volts, so we can touch them, and it feels pretty warm, so that's the electricity we feel at these cables.
Going uphill, of course, it's just the power of the motors and the electricity getting the train up to the top. But coming down, the motor actually works as a generator, and it's actually generating electricity. 80% is reserved for its braking power, but the last 20% is actually put back up into the power cables. So in theory, you could say 5 trains down and we send up 1 train for free.
Electric motors drive a rack and pinion system that transports around 5,000 passengers a day up the steep 35-minute climb.
Now we're coming up to the tunnel.
no matter what the weather is on the ground.
When we go up in the winter, we didn't have to push the snow away, it's always free, And so you can go up 365 days in the year. I think that time their only choice was to build the tunnel.
During its construction, this hugely ambitious railroad's costs doubled. But the industrious Geyer Zeller had an additional money-making project in the works. Partway up his tunnel, he created a station and viewing platform known as Icemere, or Sea of Ice. As his workers continued to dig to the top of the mountain, trains would bring paying guests to this midpoint to marvel at Icemere's beautiful vistas, raising valuable revenue.
Wow, good. In the beginning, they had some mountain guides. They go hiking with the guests, so you could go outside. I think it's very nice view. You can see in the ice, in the crevasse, you see the crevasse of the glacier.
Today, this is no longer the end of the line for the train passengers. The impossible railroad has one more mighty climb to tackle. All this work can create wear and tear that could see the crucial rack and pinion fail.
Here we have one of our drivers lubricating one of the trains.
To ensure nothing is damaged, engineers have developed a special oiling system.
These two tanks is about 10 litres of oil, and that will be enough for about 1,000 kilometres of this train to go up and down.
Every 50 seconds, the rack and cog are automatically sprayed with an 8-second burst of oil.
It not only lubricates the rack and pinion, the cog, but it also lubricates the wheels, so the track will also have less wear and tear. It is very essential that these trains are lubricated and this oil system works due to the possibility of a derailment, which, of course, no train company wants to have.
Ingenious engineering ensures the Jungfrau Railway reaches the end of the line, more than 2 miles above sea level, where its passengers are greeted by a viewpoint that would have once been impossible to reach by anyone other than the toughest mountaineers.
Wow. When people see the view, most people, they start to cry. What can I say? Before, only by foot you can come up here. This was something special for people.
The entrepreneur Adolf Geyer Zeller never got to enjoy the spectacular view. Though he died before its completion, his impossible railroad remains as his legacy, having conquered this great wilderness.
Today, if someone said to build a train through these mountains, you would think they're crazy. But this happened. 105 years ago, they completed it. It happened.
These mountains pose multiple problems for engineers. Around the world, railroads must cross many diverse landscapes. And the jungle presents an altogether different wilderness challenge. In Thailand during World War II, prisoners of war had to build a railroad once thought impossible. Each year, thousands of international tourists make the journey to the Kanchanaburi region in southern Thailand. All of them drawn to the magnificent landscape and a once unthinkable wilderness railroad line. Around 3 trains a day make the 2-hour journey from Kanchanaburi Station, north to Namtok, and the waterfalls of the Sayok Noi National Park, near the border of Myanmar, also known as Burma. It's a popular trip, but this is a railroad that was once thought to be impossible. Since the 19th century, a wilderness railroad had been considered between what was then called Burma and Thailand. but was thought too difficult and dangerous because of the many rivers and dense, hilly jungle. But the middle of the 20th century brought a brutal new world order. In 1942, during the Second World War, the Japanese army captured the British colony of Singapore, enslaving more than 200,000 local residents and 60,000 Allied troops, including an injured 23-year-old gunner, Fergus Ancorn.
The Japanese came into the hospital, then they went out with the walking wounded. And I said to the man lying on the stretcher beside me, "What's going on?"
Fergus and the other prisoners of war were eventually sent to build what is now a major tourist attraction, the Thai-Burma Railway and the infamous bridge over the River Kwai. By using a workforce made up of forced laborers from the local population and prisoners of war, the Japanese military had decided they could build this impossible travel route, almost 250 miles long, through the jungle, and use it as a supply route for their armies. The brutal conditions that led to over 100,000 fatalities earned it the name the Death Railway.
The working day, up at dawn, handful of rice to eat, working 18 hours, 30 degrees of sun. Within 2 weeks, we didn't know the days of the week. In the jungle, of course, it was virgin jungle. No one had ever been there. And we had no contact with anybody. And I used to think, I wonder if the war's over. Who won?
For those building this railway, the infamous bridge would not be the end of the line. On the cliffs beside the Kwai Noi River, Fergus Ancorn and his fellow POWs and enslaved local laborers would be made to build one of the most extraordinary and iconic engineering features on the line, the Wangpo Viaduct.
Well, the Wangpo Viaduct was an immense affair. It was nearly a mile, I think, and it's round the side of a mountain, about 100 feet up. So we had to blast the mountain away with the dynamite. Very, very dangerous. It was the only job I was on where we had to have elephants to help us.
Today, tourists, including Matthew Bell and Philip Holmes, make the precarious journey to experience this remarkable railway.
Fairly vertigo-inducing, actually.
Constructed mainly by hand, local enslaved laborers and prisoners of war built a teak and concrete trestle that clings to a ledge between the cliffs and the river below. But this was engineering the prisoners were hoping was not built to last.
Apparently, the prisoners of war tried to sabotage the building of the bridge by collecting termites and putting them into the woodwork frame of the original bridge.
That's a bit of a, what do you call a long-term plan?
Yeah, definitely, yeah.
We assembled it, and on every joint, we put a handful of termites in every joint, hoping they would eat the bridge when we'd gone. I found out later that they don't like teak. It's hard, they can't do it, so they're still there.
Do you know what? Could you imagine being in that situation then? You had no idea how long the war was going to go on for.
It has been recorded that 2 shifts of 1,000 men each worked day and night continuously, completing the Wangpo Viaduct in just 17 days. Despite mass malnutrition, dysentery, and malaria among the workers, the entire railway with nearly 700 bridges and viaducts was completed in less than a year, but at an enormous cost of life, with over 100,000 fatalities.
It's just so sad. It's just so tragic. How could you stand up and be counted? It's just so anonymous. Yeah. It's just one of the many number of people who died. I just think it's tragic.
I mean, you've seen the film, right?
Yeah, of course, yeah.
I hear that You know, that doesn't even come close to the terrible conditions that these people suffered.
After the war, most of the Wilderness Railway was soon reclaimed by the jungle. What remains is a tribute to the workers like Fergus who survived the infamous Death Railway and the many thousands who didn't.
I mean, one per viaduct, imagine building that by hand. So we did a good job. It always beats me how the Japanese, who spoke no English, and the English, who spoke no Japanese, built a thing like that viaduct.
Whether crossing jungles, deserts, or mountains, the challenges facing a wilderness railway are often apparent. But sometimes hidden problems lie beneath the surface. In Scotland, engineers must figure out how to get across a giant bog. For railroad engineers, nature's obstacles are usually plain to see. They can go through them, under them, or over them. But sometimes the challenges can take you by surprise. The West Highlands of Scotland, a beautiful wilderness enjoyed by millions of visitors every year. But in the late 1800s, this wild terrain filled train engineers with trepidation.
Back in the 1880s, when people were building railways all over Britain, Scotland didn't have that many railways. And the rich fishing grounds of the west coast of Scotland meant that it was absolutely imperative to try and get a railway built down to Glasgow.
Linking the valuable resources from the Atlantic to the rest of Britain would require a daring railway solution. The West Highland Line. Stretching 123 miles from Glasgow to the Highlands Fort William, the Wilderness Line crosses dense forests and extreme mountains, landscape to challenge any rail engineer. But what makes this impossible railway is perhaps the route's most innocuous scenery, the stretch of land called the Rannoch Moor.
I never get tired of this moor. I never get tired of the views to the mountains in the background, the small plantations of fir trees.
It may be flat, open terrain, but the 50-square-mile moor presented a potentially devastating problem for the railway's engineers, as historian Doug Carmichael is about to find out when he follows in their footsteps.
I'm not quite sure we're going to get across this.
Rannoch Moor is essentially one giant bog, wet, muddy ground.
You can just see how soft the ground is underfoot here. On face value, building a railway through here looked like an impossible task. This ground can hardly support my weight, so you can imagine the challenge there was for the engineers to put a railway over it.
With a soft and unstable foundation, the railroad's plans were sinking fast. Engineer Charles Foreman was part of the team that solved this shaky wilderness problem.
The idea was he would use the resources around him. First of all, he took large quantities of this brushwood and laid it on the bogs. Then he took even larger quantities of branches and timber, and then he took turf from all over the moor and laid that on top of the brushwood.
Foreman then topped off this layer with a mixture of crushed stone and gravel, called aggregate.
And we get all the aggregate out, and we put it on, and finally, I'm going to prove that it works. And it works. The railway did not sink anymore.
Constructed over the course of 5 years with up to 5,000 workers at a time, creating the 23-mile stretch across the Rannoch Moor was perhaps the West Highlands' most hard-won achievement.
I can't imagine what it must have been like all those years ago to build a railway through an environment like this. Quite an incredible achievement.
One area of the boggy moor, however, would need much more than sticks and stones.
They got to here and they found that there was a 1,000-foot wide depression, so they decided they would have to build a viaduct. They had to dig down through yards and yards until they finally hit boulder clay, and they were able to erect these towers. And eventually a 9-span viaduct took shape.
Almost 700 feet long, Rannoch Viaduct is the second longest segment on the West Highland Line, beaten only by its most famous crossing, the magical Glenfinnan Viaduct that has captured the imagination of train enthusiasts and film buffs alike.
The West Highland Line breathed life into remote communities, and more importantly still, tourism came to the West Highlands.
Thanks to inspired solutions, this impossible railway has opened up Scotland's wildest lands. But for some railways in the world's most extreme locations,
in a bad winter, we can expect 4.5 meters of snow. You have to be good prepared to stay alive here in the winter.
overcoming Mother Nature can be all but impossible. From uncharted territory to sinking ground, engineers are an ingenious bunch. But there's one thing that can outwit them: the weather. And in an isolated wilderness, that can be a massive problem. Norway, home to a vast frozen wilderness where winters are some of the harshest on the planet. With some areas engulfed by snow for up to 5 months of the year, it's no wonder this is one of Europe's most sparsely populated regions. As project manager Carl Morten Undal is well aware.
As you can see here, the landscape is, we are alone here. It's about 15 kilometers to the nearest station where people are living, so we are totally alone up here.
This remote Norwegian environment receives huge snowfalls, creating drifts 10 feet deep. Yet unbelievably, it is home to Northern Europe's highest rail route. The Bergen Railway.
We have a railroad crossing through one of the most beautiful parts of Norway. So I love my work.
During the 1800s, the only way to travel between the major cities of Oslo and Bergen was a week-long voyage by ship. But in 1909, they were connected by this ambitious railway. Traveling east to west, the line first passes through pastureland, but on reaching Geilo, it climbs more than 3,000 feet in just 62 miles, as this railway enters the Hardangervidda mountain range.
Compared to other railways, I think it's extremely challenging when they did that more than 100 years ago.
But former railway engineer Inge Hirtas is under no illusion. Keeping the railroad open is an even bigger undertaking.
In a bad winter, we can expect 4.5 meters of snow. You have to be good prepared to stay alive here in the winter.
At 4,100 feet, Sanda, a snow-swept plateau, was once the most notorious section of this wilderness railroad.
This section of the line was the worst when it comes to snow problems. We have to clear the snow 24/7.
Now, this section of railway has been beaten into submission by relentless Mother Nature.
So we had no choice. We had to abandon this track.
Just over 6 miles away, Carl and his team must somehow protect the operational line over an 18-mile weather-beaten stretch.
On the rest over here, we're going to build around 60, 70 meters this way.
Okay.
To catch some of the water coming down from the mountain.
The snow together with the wind will fill up this railroad on just 20, 30 minutes on a rough winter day.
Ensuring the impossible railway remains open calls for an inspired solution in one of the world's most unforgiving landscapes. In the frozen wilderness of Norway, it's a race against time. As the snow piles up, engineers must find a way to keep the Oslo-Bergen railroad line open. On a rough winter day, it can cover the tracks in as little as 20 to 30 minutes.
That's not enough time to us to keep the line open with a snowblower. So we need to also have the snow shed protection.
Around 7.5 miles of snow sheds cover the track, keeping up to 23-foot snowdrifts at bay. But many have been in place for over 50 years.
We're now walking into the old snow sheds built up in a wooden structure with aluminum plates outside. And some of them are actually now in really bad shape. In the summertime, we had water problem here. In the wintertime, icing. And of course, that is not very good for the wooden part here. As we can see, it's rotten.
To keep the railway running, Carl and his team are currently modernizing these aging weather defenses.
Now we're building up a new one with steel and steel plates also outside. Steel will come up on this concrete wall here. In the winter time, tons of snow will pressure on this wall and we need to secure it safely. Without snow shed protection in this area, it will be a very big challenge for us to keep the railway open.
But even snow sheds couldn't save the section at the now desolate Sanda Plateau. Avoiding the weather here called for a monumental construction project. A daring $63 million 6-mile tunnel cut directly through a solid granite mountain.
It was opened in 1993 after 3 years of work. And it has made the line much more reliable, and it has reduced snow clearing costs with about 50%. So in around 13 years, this tunnel paid itself.
This engineering success story is just another chapter in the extraordinary history of a truly pioneering cross-country railway.
The Oslo-Bergen line was really a revolution. The line has been very important for more than 100 years.
This line is a lifeline for support the western part of Norway. I would say this is one of the most incredible railways in the world, Bergen Line.